everyone. So apart from the title, I want to add that this activity has been funded under the GSTP program and has been supervised with European Space Agency ESOC. So Juicy Roberts is our TO there. And we have also been helped by Telespazio Germany, notably for the environment, which we'll see afterwards. So the motivation necessary for penetration testing and automating that, one is that, I think I don't need to spend a lot of time here, is that security is more and more important, and especially for space, since it's also more and more attractive. And before I go into the detail of why we automate, let's first go into the detail of what is a pen test. So it's an authorized cyber attack performed to evaluate the security of the system, to identify both weaknesses or strengths, and to basically complete a risk assessment of the system that is attacked. Notably, it's carried out by security experts that have a deep know-how in how to attack those systems. They don't need especially deep knowledge on the system itself, but especially how to attack those. There are various types of pen testing, basically approaches. One is a black box, which is you have no information about your system. Then you have the white box where you have everything, source code or whatever. And of course, in between the gray box. So our goal is, of course, to be able to do those kind of pen tests. So, and we want to automate them. So why do we need or want to automate them? Because manual pen testing is very expensive and time consuming, and you need those experts to be there and have time. And also because of the expensive part, they are often overlooked in terms of where we spend the money to do other more critical tasks. So if we automate pen tests, we are kind of solving part of a problem, which is at least have a minimum set of security tests that are executed against the system to have a more reliable tests. And also, one of the interesting parts of automating it is it's repeatable. So this means that you can actually also use your pen testing during your development when you're still adding features and seeing if your features are making security worse or better. So now bringing all this to space, and that's the hard part actually, because as you probably know, there are already tools that exist for pen testing. Some are automated, some not. But what space needs is being customizable and flexible because they have very specific protocols, very specific systems. So the scenarios we are executing to attack a space system must be very specific and must be tailored to the actual system that we are attacking. To be effectively able to test ground systems and also bringing back to more standards like the MITRE attack, which is, okay, IT generalist, but we have also Sparta, which is specific to space. So being able to put the scenario in the context of those frameworks is also important to be able to relate to how are we and where are we in our security for that system. So for space, we need specific tools and testing techniques. This means also custom tools. We can't just rely on the hacking tools that are out there because those will notably attack maybe Windows, Unix, but not necessarily Solaris or old systems or newer systems that are deployed in space. So that's kind of a problem. And also, because of space, because of the rigorosity we want, we need to be able to have more than just testing. We want feedback from those tests, whether, for example, some requirements are properly implemented or not, to be able to put this information back into the risk assessment and evaluate how well is my system doing now. So a bit of history on this project. So this is actually the second iteration of an existing project, which was the PenBox. You may have seen the PenBox. There was a name of it in a previous presentation today. So PenBox is an automated penetration testing tool, and that's the one we developed in 2018, more or less. And now this is the second iteration. So the second iteration is mostly to improve what we did before, to make it more industrialized and being able to deploy it in production. So that's the goal. In terms of automation, Penbox was already not too bad, but now we want to have the space-specific parts working. So when we compare Penbox with other existing tools on the market, we didn't compare them all, but we took the ones that are best known. So we see that, okay, Penbox was not doing that well, but we can improve a lot. And what we see also is that in terms of general hacking capabilities, the other tools are quite well placed, and they will complete the task well. I will not go into details because I don't have the time to do that, sorry. But now if we take that to space-specific hacking capabilities, that's where the problem is, basically. If we take Pantera, for example, ability to add space-specific scenarios or even adding your own tool is complex. You need to contact the vendor and so on. So that's not something that you can really do many times. You will do it maybe once and then you can't. And that's not something that you want. And there is also the customization. So maybe even the problem is we don't know yet what are the systems that will come in the future, and they are still specific to space. So we need to be able to customize them now and also in the future. So we want to allow this to have its kind of a toolbox rather than just a tool that is able to execute a specific built-in scenario. So we basically don't like built-in. We rather have flexible and extensible. Yeah. So so ACT is the new name of that solution, which is basically Penbox 2, if you can call it like that as well. So we, based on the strengths of Penbox, automating pen tests, we added the ability to have space-specific attack scenarios. And this is mainly a user interface problem that we had. Is in Penbox, the scenarios were basically code, and now they are click scenarios that any engineer or security engineer can use. And you will see that in a video or demo, but it's a video because it's much simpler to handle. We want to also be still flexible enough to use existing tools, hacking tools that exist, so we don't want to reinvent the wheel, of course. And still also add custom tools. And this is the other part. To make everything maintainable, we needed to have a new strategy, which was not too bad in Penbox, but now we improved it much better. And Xavier will explain this in a bit more details. Yeah, make it deployable. As I said, we want to have a production-ready tool, so something that can be easily deployed and set up in any kind of environment. And finally, MITRE and Sparta I already explained, and I will explain later on a bit more details there. Interoperability. So you've seen the talk from this morning, which was about, or InFast was using Penbox as a tool. But it was not ideal because the API of Penbox was kind of limited. And now we basically fixed that part where the API can do everything. So meaning that if the scenario mechanism in Penbox 2 ACT, if you don't like it, you can just use the API and do everything from the API. So as I said, scenario customization is one of the key features. So we have now user-friendly graphically web interface where you can just put your scenario there. And also there, since we want something that is extensible, we want to be able to implement kind of any kind of logic, even more complex, where based on the results, you look at the results and you decide on what is the next step. So this is the kind of things that we want to be able to do. And so that means that the tools are executed based on the results discovered during the execution. So it's not a static scenario. There is dynamic evaluation there. And there is also some, of course, threshold to avoid attacking our target too much. So we have certain threshold to avoid this. So basically, we wanted to have versatile scenarios where we can do black box, white box, and also more, actually not attacks, but verification. We want to be able to, for example, connect to a remote machine, grab the configuration, and evaluate whether A, the attack worked, yes or no, or B, some verification of the security requirements, whether it's properly implemented on that system in production, for example. So scenario contextualization, you can write your scenarios by, or create your scenarios in the user interface by selecting the exact tool that you want, Nmap, Nessus, or whatever. So that's one way to do it. But sometimes either you don't want to be that detailed, or you prefer to put your scenarios in the context of a given framework like Attack or Sparta. In that way, we have provided a way to do that. Instead of mentioning the tool, you just mention the tactic that you want to use, and our tool will then automatically select the tool that is associated, so the attacking tool that is associated with that tactic. So that way, if there is a new tool that is able to do network scanning, then we can use also that new tool given parameters. For example, if it's much better, much faster, and so on. So you can also easily modify, or it is adaptable also if you add new tools. The rest of your scenario still works, basically. The limitation that we introduce is also to avoid being too noisy. So maybe you want to test your SOC and you want to see whether your scenario triggers some alarms. So you want to have a very discrete scenario that just doesn't attack among, for example, during 1 week, and see if your SOC is able to detect it, yes or no. So they would set the noise level to very low. Or you don't care and you just want to break things, then you'd set it to very high. The same with disruptiveness or time limit. So that's kind of the cursor that you can set depending on what you want to do. So the next part is presented by Xavier. He will explain what scenario chaining is.
Yeah. So we saw previously that we want to provide the ability to create a custom scenario for the users, but we also want to go a bit further than this and to provide the ability to do some scenario chaining, so to have a follow-up scenario that will basically use the result find for the first scenario. So you first execute a scenario, you find some results, and we want to propose like a next step, another scenario that based on the first result is able to find more stuff. An example of this is that if you first do a scenario where you simply aim at finding, for example, a backdoor or an access to a system, once you finish, well, the scenario is finished, you have your backdoor, that's great. But then we can propose, wait, there is another scenario which is more like a white box that assumes that you already have an access, not that you found it. What about you do this scenario that will use the result you found to continue on something else and find even more results. Another advantage of AACT is the way we developed it. We try to make the architecture as flexible as possible, but more importantly, we decompose the architecture in small components that we containerized. So we put each component in their own container with all the dependencies. This is even more relevant for the different tools that we can use, because like this, they all have their own container, they all have their own environments with everything they need. So it means that first of all, they are in a way a plug and play. You can just launch them. They have everything they need. But also it helps with the maintenance of the tools. Because if we need to add a new tool, we just need to add the corresponding container with all the necessary dependencies. But if we need to update one, we just modify the one we need. There isn't how should I say? It's way easier to maintain compared that if we had everything on the same environment, for example. It's also easy to remove one if it's outdated, for example. On top of that, it was a bit mentioned previously, but we made it such that it's easier to interact with it, specifically compared to the previous version, which was the Penbox. So we basically opened the API such that an external module can call ACT features and use them directly. That would be for like, how should I say, high-end features like low and more direct. If you don't want to use all the scenario chaining and features, you can also just use the API to say, I want to launch just this tool, please give me the raw output. So like this, we open the possibility to interact with AACT. So now we will present a little demo. Is it displaying? Well, great. So this is what it looks like for now. So the idea is that we can create a scenario from scratch, from nothing. The only thing you need to do to start is to place a first node, a first activity, let's say. Of course, we recommend which one is the most suitable based on the situation, based on what you already have as a result. For the first one, this is all the kind of tools that can be used with no informations. As it was said previously, you can either, if you are experimented user, clearly select which tool you want, but if you don't really know, you are less experiment, you can just say, I want a network scanner, and the software will manage in the background which kind of tool can do this and produce what you want. Another point that was important for us is to help the user to build efficient scenario or scenario that works. So we will always display the validity errors, meaning that if you build a scenario which is not valid, it cannot work, we are gonna display the error simply to help the user to fix the scenario in a way that we make it easy for someone which is maybe less experienced to build a scenario from scratch. In this demo, what we want to do is we want to find a backdoor on the system. So we're gonna put the necessary tool to arrive to this objective, and we're going to start the scenario. So we can see the first one is running, and one important point is that the two next one, we can see with the little blue dot, are running in parallel. So every branch of the graph will be run in parallel. We can see the results. Now we're going to focus a bit on the result. We can see the result appearing as soon as the tools finish. So we can see we found some CVs, anyway. And we did manage to find a backdoor. Of course, there's a lot of results, so we included a search feature to be able to find what you were looking for. In this case, we simply search for backdoor, and one interesting little feature we added is that we can see the backdoor session in yellow, but also in the scenario graph, we can see that the tool that produced this output has been also highlighted. So if you have a more complex scenario, you can see what tool managed to bring the output we were looking for. Another little feature we add, because of course there's a lot of results, if you want to filter the result and only show something, for example, for one IP, what has been found on this IP, because I want to know exactly, we can use the filter feature that will simply show you what you were looking for. So we can simply see, we detected this IP and we found a CV and a backdoor type on this IP. So that's it for the demo, and I think Tom will just do this.
Yeah, so switch mic. Thank you. So the next part, we had a video, but unfortunately, I'm not allowed to show it because there was some sensitive stuff in it. I will show you screenshots, which I could redact sufficiently. And that's where Telespazio came in. So the demo from before was done on our lab. We have a few very vulnerable machines. And also, of course, as you can have guessed, the video was sped up because the results don't come as instant as you saw. So we don't speed up the tools. There's no magic there. Okay, so what Telespazio has set up, a full environment, it's very close to what Peter Frank has already presented in Alexandra yesterday. It was yesterday. So I won't go into many details here, but basically we have a representative environment. Some parts are the actual software, and some others are basically the mocked application or a simulation of it. It's as representative as can be. And unfortunately, we cannot test in production yet. So they don't trust us yet enough for that. But maybe we'll get there. OK. So here is a video. No, it's a screenshot. So you see, there is a bit of redacted because this is on that environment. And one thing I wanted to show here, so the previous one was without any interaction, and it's basically just run, and that's it. But we can also have some interaction if your scenario is kind of dynamic, and you want to have, at some point, you look into the system and you extract some information. So that's what we are doing here, actually. We are basically, this scenario is about changing a date in a database. So, and we ask the user, okay, give me the ID of the line you want to change, of the activity you want to change, and give me the date that you want to put instead of whatever is there already. So that's what we are asking the user here. So this is here, the dot in the video disappears, and then you have to fill out this form, and you have just the key and the values here. Okay? Opla. Sorry, I forgot I did screenshots. So this is the MCSEC, so the system on which an operator would work on. And there we have the line that we want to change with the date 2024. And once we have entered the information, we have our ID of the line, sorry for the pixels. And there, you can't really read it. Maybe it's here actually better. We set it to 2030. So the idea is that we set a date in the future, but we could also set it in the past. And that could mean that the line, whatever was shown, the activity, might disappear from the screen of the operator because it's in the past or in the future. So that was the intention there. So the other thing that we see here is we actually have also here a backdoor. So that's how we will work. It's kind of the same. The first steps are kind of the same. We found on our network, here we have our IP address. And then here, to simplify things in the scenario, we just write attack because we know what vulnerability we are looking for, which is the one that is redacted here. So we found our vulnerability. And we found our backdoor session here that allowed us to change the database content. And now if you go back to the tool, after some refresh, we see that the date is effectively changed to 2030. OK, this is a very simple example we have here. Because of sensitivity, I couldn't even show a more complex thing. But that's basically the gist of it. You can basically implement your own scenario and then try it out. And then if you don't like it, you just, as we have shown in the previous video, you can add nodes, add complexity, or just run a full scan of Nessus, for example, or GVM, what we are using so far. Yeah. So I can't show much more for now. So this is still a work in progress. There is some reporting that will come. And there are some features that we'll also have in terms of tooling. So you will be able to, for example, to have a node that decides based on the results, what is the next branch in the scenario that you want to execute, for example. And you can actually execute any kind of logic, like transforming a result into base 64 or whatever you need, basically. So we hope we have achieved what Penbox could not yet, a low-code interface that allows kind of anyone to just implement the scenario and try it out, which is what we wanted because the security engineers for space will have an idea of what to test, but most of the time it's too confidential or too sensitive for others to be involved. And as we have said, pen testing is a very costly endeavor. So here it's kind of a first, we can do a first try with that, play around, and then once we know a bit more, we can send the actual pen tester on the right path and then dig deeper in the details. You haven't seen it, but it is very simple to integrate new tools. It's basically a Docker image. That's all you need. There is a bit of integration there, but not much. And that means also if you have a custom tool, a custom script, you can integrate it and then have it as a clickable option in your scenario. It is fully offline. We don't need necessarily internet. There are some tools that may need internet. So if you have, of course, a tool that is scanning on Google and trying to find email addresses, which we have, by the way, as well, then, of course, you need internet. But otherwise, it's not 100% necessary. And the main thing that you can do with that is have recurring tests, repeatable tests. You can do scenario chaining to dig deeper in a scenario. And then once you have something that is kind of nice, you can just run it again and again and try to fix, for example, the firewall, fix your software, or both, and then see if you have any differences in the results or if your patch basically worked. That's all for us. And then now, if you have any questions, shoot away.
Well, thank you very much for that presentation. That was great. I should note, just before we start questions, that the session that was scheduled for after this one has already been rescheduled to this morning. So this is actually the final session in the central room within this CYSAT conference. So keeping that in mind, who has some questions for this final session?
Hi, if I recall correctly, you said the scenarios are chosen based on results of a previous scenario. How is this chosen? Is it something you write yourself? Is this a smart algorithm? Kind of thing?
So that would be something that you can write yourself. So there might be algorithms. For now, we don't have them, but you could implement them. So it's basically a Python function that you can implement, and based on that, you can implement the logic that you want to select the next step, basically. Yeah.
Any additional questions? Oh, yeah.
Thanks. Hi, Tom. Cost, price, licensing?
GSTP. So the licensing is basically, it's a GSTP project. So ESA will maybe open source it, I don't know, but I guess that's the idea behind. So yeah, for the empty barebone pen box, that's basically, then there may be some tool integration. So for the tools, it's not a matter of not us want it, but it's more or less a problem of IPR and licensing. But you can then add your own tool. I don't know how it will be shipped in terms of tooling, but at least the mechanism and everything will be there. So the project is about to end in, let's say, 1 or 2 months, and then I guess it will take some time to publish it. So everything is automated in terms of building. So that's part of the fully automated in CI/CD. So the tools are also built in CI/CD. If you have a script, you can put it there, and then it will build your Docker environment and everything. Yeah, John?
So you do the scan, so you do the automated pen test, you get the report. You've got remediation and tracking. So if I run it through again, it tracks however improved. And
that will be in the future. That's definitely a feature for the future. We won't have time in this project, but yeah. That said, we haven't. There is something that we haven't told here is about the requirements verification. Additionally to the attacks, we also do some requirement verification where in the background we check the results and see if something shows us that a specific requirement was not implemented. For example, if you have a very weak password, like password, in your results, then you know that your system is not implementing your password policy properly. So that's one simple example I can give.
do you have a roadmap for improvements? Features coming?
So this tool will also be a product on our side. So there, I don't have a roadmap, to be honest, yet. But there are many ideas that come there. And I believe also on the ESA side, there are some ideas to follow up there as well. Yeah, I hope.
Just pop the next question on the screen. So does the framework include any AI automation that allows to predict or recommend any possible next pen test stage?
So no, we don't do the AI part, but we have the full API. So you have full access through the API. So you could very easily implement that. And that would be actually the exact thing that you would do, analyzing the results and deciding which is the next scenario would be a good task for AI. Another good task for AI would be analyzing raw results in a Wireshark capture, network capture, where you check for interesting information and so on. So analyzing results, but so yeah, it's possible very easily, actually, if you do the work.
Cool. Are there any other questions in the room? No?
I think it builds up on the AI question. When you have results from a first tool, you get a lot of results, and then you have to rerun all of these results for the next tool, right? So at some point you have like an exponential explosion of how do you actually handle this?
No, we don't rerun the results. We use the results from before to continue on that.
Yeah, but for most automated tools, you're gonna get like huge bunches of results. Like
yeah, that's the work we did basically. You can see part of it here, where basically you have the results, they are structured. So that's part of the integration of the tool.
So you've tested that like on a very big system, your process is able to scale. It doesn't like explode the moment you run, like for example, an Nmap. It gives you a ton of IP addresses, and then the next part of the scenario is saying test individually each of these IP addresses for a specific test.
Yeah, okay,
Doesn't
right.
It like
yeah, okay, I see what you're, yeah. So there is, if you have really this case where you are really in a big company and you have to run that, then either you can let it run, it's automated, you don't care. Okay. That's one way, or the other way, which is, I believe it's shown in the video. You can have a glimpse of that. Where is it? It's in the parameters. Okay. There it is. So you have execution rules here, which are basically rules you can set up for your scenario. You say, if this IP is there, don't go there. This is typically what you want to do, not attack yourself, some firewall, something you don't want to be touched by the scenario. And you can also do the opposite. If you see IP addresses in that range, then go. If not, then don't go. So you can set rules to limit these kind of problems. Or you can also set it up in your scenario itself by the function nodes. So where you implement the function and you say, you filter basically the results and you don't let the others go through. So that's the other way you can do it. So it can either be hard-coded in the scenario as a function node or dynamically selected by the user when he configures his own scenario. So there are templates and so on. When you have a scenario, that's what we have at the very beginning. You see various templates here that you can choose from. It's not there, actually.